Hello everyone, welcome to the Mathematics Enthusiast, and today I have come across a new problem from relation and functions, so let's have a look at it. We have to find the domain of root cos x plus root x plus x minus 1 into 2 minus x. I will tell you an innovative method how to find this because it is a little complicated function, but we'll try to find the domain of it. So if you want to give it a try, pause the video and then continue for the solution. So here the solution goes like this. Now the main theory behind this is, as we know, means what if we do this and we find the final domain. So in the final domain we take the intersection of the individual domains of both the functions. Like we find the domain of root cos x separately, then we find the domain of this function separately, and then we take the intersection. That will be the final resulting domain. But here we see that root cos x is rather a little complicated function. Okay, a little complicated function to be defined means it needs a knowledge of graphs. Okay, but the method which I will tell that also involves knowledge of graph, but this whole function altogether is little difficult to calculate. So I will tell you an easy method that how you can apply the theory which I said on this question. So for what we can do, we can find the domain of the one of the two functions which is easy to find. Like here I look at this one, this is somewhat easy to find. So as we know that if any function is in square root, so for any function a to be defined, a should be greater than or equal to 0, obviously, because square root cannot tolerate negative charge inside it. So what we can do here, so we get this inequality. Then we can solve it by any way that you know, and if you know any other way, then please comment me in the comment box and let me know. So here this we can find, and by using the wavy curve method, here plus minus plus, we want this part, means everyone have different types, different ways to solve it, but I have this way. So here the final answer will be 1 by 2 in the closed bracket, because we want is equal to 0 as well, so we have included that. So here this is the domain of this function. Now for this function, what we can do, that we can check the values of x in this region. Okay, in this region on the graph, means the graph of cos x. Like let's say if I draw the graph of cos x. Okay, here it is. And it goes on infinitely. This is what I am labeling sum. This is pi by 2. This is pi, and this is 3 pi by 2, and so on. So now what we see that this is 0. So this pi by 2 value is somewhat around 1.57, so 1 will lie between them. And here this is 1.57, this is approx 3.14, so 2 will lie between them here. So now why we are bothering about 1 and 2, because we have got domain here 1, 2 in the closed bracket. So we will see whether in the graph of this cos x, in which region it is defined. So here we see that this region from 1 to 2 is suitable for it, but we see that we don't want the domain of cos x, we want the domain of root cos x. So this negative part we will neglect. So now we get this part only. So this I am highlighting it. Okay, I hope you can see it. So this highlighted part will be our domain, and this will be our final domain, because we have used the first domain as well and we have found the second domain as well. So we have taken the intersection of it, and this will be our final domain, that is, let's say it is df, which will be equivalent to what, taking from 1 to pi by 2 with a closed bracket. So this will be our final domain. I hope you liked this video, and if you have any other alternative to this, then please do comment me in the comment box. Okay, and please subscribe the channel for more such exciting problems. We'll see you in the next video. Till then, goodbye. Thank you.